Okay. Well, hello, everyone. My name is Tracy Dean, and my full-time job is actually I'm an offering manager for both the IMS tools that IBM sells and some ZVM tools that IBM sells. But in my spare time, I use Rexx and teach a little bit about Rexx. I started learning Rexx on my first day at IBM as a summer hire. It was a very new language at that point, and I needed to learn it to do a project they wanted me to do for the summer. So I've been using Rexx for over 30 years now. So today what I'm going to do is do the part one of today's presentation. I'll talk about what the Rexx products are, external environments and interfaces, instructions, functions, and subroutines, variable, visibility, and parsing. And that's usually where I run out of time for 1 hour, and so we'll pick up part two next week. Now, what I'm focusing on here is not, normal things you would do in a procedural language like if-then statements and do loops, those kinds of things. Those are pretty basic things that any procedural language has, and that you can go, look at the books or the helps to find the syntax. What I'm going to focus on here are things that are a little bit more unique to Rexx to help you understand, how Rexx can help you, and maybe a little bit about where maybe Rexx gets you in some places, and you'll now understand how to get around those things. Okay, so let's get started with part one here this week. So as I said, Rexx is a procedural language. That means the code is executed line by line, so it's interpreted, if you will, as it's executed. This Rexx interpreter is included in all ZOS and ZVM releases. So everybody who has ZOS and ZVM has access to Rexx because you have access to this interpreter that will run the code line by line. There are situations where you might have compiled code. So if you have compiled Rexx code, then you do need the Rexx library. And for people on ZOS especially, that's not an LE language, so you do need a separate library to run that compiled code. If you do have compiled code and therefore need a library, then you really have two choices here. You can get a priced product from IBM, or you can get a free download. And you might wonder, why would I pay for something that I can get for free? And the answer is, if you're using the free download, it's actually executing the code through the interpreter, so it's still being executed line by line. You're not getting the benefit of running object code or compiled code. At execution, though, Rexx will figure out what you have, whether you have the real runtime library or this free alternate library. You do not need to worry about configuring anything or telling the system which Rexx you're using. You just run your Rexx code and it will find the right library, or the interpreter if you're running the source code. So I talked about this compiler and library. These are separate products that IBM actually sells. So there's an IBM compiler for Rexx, there's an IBM library for Rexx. Those are both the priced products. And we'll talk on the next chart about why you might want to compile the code, right? I already told you you can run it for free through the interpreter, so why would I want to pay for a compiler or a library? The alternate library, for those who are using ZOS at all, it's included in the base operating system, but most of you, of course, are VM, and so you need to go download this alternate library if you needed to run compiled code. And actually, many of my ZVM tools customers who are using things like Operations Manager, Backup and Restore Manager, Tape Manager, they typically go download this alternate library because some of the code in Backup and Restore Manager and Tape Manager specifically is compiled. So they need to get this free library to run that compiled code. But again, you do not need to buy anything just to run and write your own Rexx. We do have the interpreter included in all our ZVM and ZOS releases. So why would I use the compiler, right? Why would I compile my code when I can do everything for free with source code? Well, in reality, it's typically vendors who are compiling code, such as IBM, shipping our code compiled. And there's a couple of different reasons for that. One is the performance of the program. So if you're staying within Rexx and not running commands that reach out to the operating system very often, then you're going to get better performance, of course, with compiled code. Vendors also might compile the code to protect the source code so that the source code is not included and visible in the deliverable. And the other reason for anyone using Rexx who might want to compile code is because when you're using the interpreter, remember what I said is the code is executed line by line. What that means is there is no syntax checking until the code is executed. So if you have a syntax error in a line of code somewhere in your program, and maybe it's in a branch of the code that is not executed very often or is a difficult error situation to create, you will never execute that code with the interpreter and discover that syntax error until you find the situation where the code is actually executed. If you use the compiler, on the other hand, then you're going to have much better productivity and quality because all of that syntax checking is done for you right up front. And then, of course, there's other directives you can use with the compiler. So if you wanted to include the date, copyright information, et cetera, you can use those as well with the compiler. Okay. Let's continue on. So let's talk about Rexx external environments. And what this means is you're running in your Rexx program and you want to reach out to the native running environment to do some kind of action. And so we'll see some examples of that as we go through. So I'm going to include in here, in the presentation, I've included ZOS and ZVM information. I know the bulk of this audience is ZVM only, but I know some of you also support ZOS customers, and so I'm going to make sure I include some information on ZOS as well. So the first example of external environments is TSO. And the way we reach any external environment, if we want to issue any command outside of the Rexx environment, we use the address instruction or the address statement. And so the example here is if I wanted to issue a TSO command, I would say address TSO. And there are many host command environments available in ZOS. We'll list them here in a minute and give an example. And there's just a few that are really used in ZVM, and we'll give a few more examples of those. So for example, here's some examples if I wanted to reach out to TSO or reach out to MVS. I just say address TSO, and then the command I want to execute in quotation marks. Now here you'll notice we've used double quotes to surround the command. You could use single quotes, but in this particular case the user chose to use double quotes because the single quotes are actually part of the command syntax as well. And it just makes it more readable without having to put in all the extra escape characters to get the single quotes. Similarly, we have address MVS, so if I'm issuing an MVS command, again, they chose double quotes. I could have just as easily have chosen single quotes in this case because there are no extra quotation marks within the command. And there's many more on ZOS. We can get to ISPF, we can get to SDSF, we can get to link statements, we can get to syscall, lots of places we can get to in ZOS if I need to reach out to any of these environments to issue a command. But now let's look at ZVM. So in ZVM, there are several host command environments. There's really only two that are primarily used, though. And the first one is CMS, and that is the default. And what that means is if you issue or have any kind of statement in Rexx that Rexx itself does not understand as part of its syntax, then it assumes it's an external command. And by default, ZVM, it will issue it in the CMS environment. What that means is it's treating the command as if you entered it on the CMS command line. So it's translating the parameter list by uppercasing and tokenizing it. So everything you enter would be uppercased, and everything would be tokenized into blank delimited words with any of the extra blanks removed. It's also going to follow the same search order as if you had entered something on the CMS command line. So looking for modules before execs, looking for things on your A disk before the Z disk, those kinds of things. The other major command environment in ZVM is actually called command. And this is similar to the CMS call command resolution, or it is the same as the CMS command resolution. What that means is it actually enters the command exactly as you entered it. There's no uppercasing, there's no tokenizing of the data that's entered. But what it also means is you have to now be more specific and specify the environment that you're actually running in or what type of command you're running. So for example, if you're running a CP command, you need to prefix the command with CP. If you're running another Rexx exec, you need to prefix the command with the word exec. So this forces you to be a little more specific, but it also gives you more flexibility in terms of not having Rexx take over and uppercase or tokenize the command. There's other command environments in ZVM as well. Most of these are not used very often anymore, so I won't spend time on them. Really, for your own personal use, you're going to really deal with CMS and command. And what I see as a general best practice is users will use address command at the top of a Rexx exec and then override it if they need to. But as a general default, most users will set address command as the default at the beginning of a Rexx exec. And we'll show an example here. So let's look at this example. First, at the very beginning of this Rexx program, I issued address command. That means I've now set the default for the program unless I change it later or unless I override it. So I don't have to then put address command at the beginning of every statement that I'm trying to reach out to another environment. I've set the default for myself. So I've set address command, and then later in my program I say exec my test. So that's going to run under the address command environment, but notice I had to specify exec in front of it because what I'm executing is a Rexx exec. And then later I change the default to address CMS. So now I've flipped from address command to address CMS. I now have a new default for the rest of the program. And so now I can execute that same Rexx exec by just saying my test, because that's run under address CMS where I do not have to specify exec. If I had specified this in lowercase, it would have uppercased it for me. If I had specified this one in lowercase, the first one, it would not have uppercased it for me, and I need to have an exec out there that has my test in lowercase. So in this case, I've set the default at the beginning, but then in the middle I change the default, so all future commands after this are going to be treated as address CMS unless I specify otherwise. So let's look at another way of doing this. In this case, I say address command as well at the beginning, and then I say exec my test, so of course that's done under address command. But now I can do a one-time override. So instead of setting a new default, I can just say for this specific command, I want to override my default. And I can say address CMS my test. So that's run under address CMS. But the next time I execute any kind of external command, it's going to run back under address command because that was the default I set at the beginning, and this was just a one-time override for this command. It was not setting the new default. So you can change this as you go through your program. It's usually good to set something at the beginning, though, to be very clear what your default is at the beginning of the program and not just take the system default. Okay, so let's continue on. So we have instructions, functions, and subroutines. So what is an instruction? Well, first there's two different kinds. The first is a keyword instruction. So it means there's some kind of a keyword that Rexx understands that's part of its language syntax, and so it's the first word of any kind of a keyword instruction. That would be things like do if you're doing a do loop, if you're doing an if-then-else statement, and we'll talk about arg and parse later in the presentation. A general instruction, not a keyword instruction, is some kind of a statement that performs an assignment of a value to a variable. So I have some kind of value on the right-hand side of an equal sign. I have a variable on the left-hand side, and I'm assigning the value. So that's just a general instruction in Rexx. A function in Rexx is something that you call, and it must always return some kind of a value. So the return value is actually a single result string, and we'll talk about variables later in Rexx and what are strings versus what are numbers, etc. But typically a function you're going to find on the right-hand side of an equal sign because you're taking that return result and assigning it to a variable. And we'll see some examples here. There are many built-in functions provided as part of Rexx, so before you go off and write your own little function, take a look at the Rexx books and make sure you've looked at what's already available because there are many functions already available. You can also then create your own internal functions within the same program, or you can even create functions that are a separate program that you call from within your program and maybe reused by other programs. So you can create your own functions as well. Subroutines are very similar to functions. They're just called differently because they may not return data. So functions are required to return data. Subroutines are not required to return data. If you do return data in a subroutine, it's in a special variable called result. The data that's returned in a function is actually just the result of the function, the value of the function. There's no special variable that contains the value. When you're calling a subroutine, you actually have to specify what data you want to return, and that automatically gets put into a special variable called result. And we'll see some examples here. So again, a function must return a value, so it's typically on the right-hand side of an equal sign. So let's look at some examples of functions. There are many, many built-in functions. These are just a few to give you an idea. So in the first one, I'm trying to calculate the absolute value of a number. So I've said total equals -3. New total equals the absolute value. This is a Rexx built-in function. And in parentheses are the parameters I have to pass. So it will pass the value of total. It's not passing the variable total. It's passing the value of the variable total. So this is an absolute value of -3. So new total is now 3. If I wanted to left justify a string, I could say full name equals the left of Tracy Dean and 20. And 20 says the length of the string padded with blanks. I could have specified a third parameter here that said what padding character do I want to use. Blanks are the default, but if I wanted to use some other character, I could certainly specify that. So now the value of full name is Tracy Dean with extra blanks in here to get it to a length of 20. We want to determine the type of data we have. It's always difficult to teach Rexx because you need to know future things before I can teach you present things. Everything refers to something else. So we'll talk later about variables and why you might need to know the type of data you have. But this is a Rexx function that's called data type. So here's an example where I'm actually not putting the function on the right-hand side of an equal sign. Right? Everything I've done before this, the function is on the right-hand side of an equal sign. The value it returns is put into a variable. Now I'm just taking the value of this function, I'm comparing it to the number 1 and taking some action based on that in my if-then-else statement. So in this case, data type, the value I passed it is amount owed. I'm taking the value of that variable. And I'm asking Rexx to tell me, is that a number? That's what the N means. It says, is amount owed a number? If the answer is yes, then the value of this function is 1. So I compare that to 1. It's true. So then I say amount owed equals amount owed times 1.1. If it is not true, that means amount owed is not a number. And I'm going to go to the else statement and say amount owed is invalid. So here's an example of taking the value of a function and comparing it to something and not assigning it to an actual variable. There are many date functions available to you. So date is another powerful function in Rexx that's built in. By default, if you pass it no parameters and just send the parentheses, then you're going to get today's date in this format, the day, the month, and the year, the month in the word, not the number. If I wanted to find out the day of the week for today, I could say date W. In this case, it's not Friday, but in my example, it's Friday. If I wanted to find a string within another string, I can use the position function, the pos function. I'm looking for the string day within this other string, Tuesday. And my result is going to be the number 5 because the D starts in position 5 within Tuesday. But I do not have to have, if I do not find that string within the other string, that's not a syntax error. It just returns a result of 0. So if I was looking for the letter X in the word Tuesday, I don't find it, so the result of start call is going to be 0. Okay, so those are just some examples of functions that Rexx provides. So let's move on to subroutines. So you'll notice in functions, I just said the name of the function, right? Now when I do a subroutine, I need to actually use the call statement. So I use the call statement to actually call my subroutine. So there's many reasons people write functions in subroutines, actually. Typically, it's because you're trying to do a multi-step task, but you want to execute it multiple times, right? And so you want to isolate it, you want to call it, come back, and then later in the program, maybe you call it again and come back. And so you want to write it once and use it multiple times. Other people also use subroutines just to make their code easier to read. So maybe I have a complex task that's going to take lots of lines of code to do. I'm only going to call it once, but I sort of want to separate it from my main routine and give it a meaningful name so that when someone else is reading the code, they know what that subroutine is going to do, but they don't get all caught up in all of those lines of code trying to find out where the next major task is happening. So it's just a way to sort of organize your code. But again, in this case, I'm calling the subroutine called calculate interest. I'm passing it the value of the variable amount borrowed, and I'm saying then amount due is equal to result. So remember, when I call calculate interest, it may return some data. If it does return some data, it's in a variable called result. So I'm immediately saving that variable off into my own variable, because if I later call another subroutine, then result gets reset again, right? So if I'm calling a subroutine, it returns a result. I typically want to do something right away with that result before it gets wiped out by another subroutine. So here's how I call the subroutine. Now, how do I actually define the subroutine? Well, all you do is at the end of your program, after the exit instruction, all Rexx programs should end with an exit statement. After that exit instruction, you just say the name of the subroutine followed by a colon. So here's my calculate interest followed by a colon. And now what I'm going to do, and we'll talk about parse later and talk about arg later, but basically all I've done is I've taken the value of amount borrowed and I put it into my own variable within the subroutine called principal. We'll talk about variable visibility again in a few minutes as well. So I have my own variable principal whose value is the same as amount borrowed. I do some calculation on it, and I return the value of total. So now the value of total, the value of result, and the value of amount due would all be the same. They would all have the same value at the end of this call to the subroutine. So you'll notice here I had the return statement. I passed it the value of a variable, and that's what was put into result here. Okay? So that's how you call and declare subroutines and functions. Now, how do I actually have this visibility of variables, and how do I actually declare my variables, those kinds of things? So let's go into that. So as I said, remember, Rexx is a procedural language, and the most important thing to understand about variables in Rexx is they are not declared. This is not like other programming languages where we declare our variables up front, we say what type they are, all those kinds of things. So Rexx is very flexible, but what that means is it can also get you. So in this case with Rexx, because variables are not declared, they need some sort of initial value. And the initial value in Rexx is actually the variable name in uppercase. And we'll see some examples of where that can be an eye catcher to help you understand maybe where you went wrong in your program. All variables in Rexx are also seen as a string. Everything is a string by default unless you're performing some mathematical operation. And what that means is when you're performing that mathematical operation, then the value of the variables at that time must be valid for the operation. But they might have had other values earlier in the program. They might have other values later in the program that are not valid for mathematical operations. So the type of data that's assigned to a variable can change within a program. Just because you used a number first for the value of a variable does not mean you cannot later assign something like a string to it. So it's very flexible. A variable can be used throughout a program, and sometimes it can be a number, sometimes it can be a string, etc. So let's look at an example here. This is perfectly valid to do something like this, where I say total is equal to a string. Here is some text. I then use the say statement, or the say instruction that says, write this out on the console. Here is the original total, and then the value of the variable total, which is here is some text. And then I say total equals 5 plus 3. So now I've assigned a value of 8 to the variable total that just had a string assigned to it. I do some calculation based on that. Because total is now a number, it's perfectly valid for me to do a mathematical operation, and I assign it to a new variable called new total. And then I use another stay statement to put that out on the console as well. So here's my result, here's the original total, and the value of total is here is some text, and here is the new total, which is 12, because that's 8 times 1.5. So it's perfectly valid to change the type of data that's in the variable total throughout the program. So we talk about not declaring variables, but earlier I showed you functions and subroutines where I'm passing parameters in. I've got variables defined in the subroutine. How do I determine where variables are visible when I go across functions and subroutines and my program? So by default in Rexx, every variable is visible throughout the program. So even variables that you are using in your subroutine or in your own defined function are visible to the main program, unless you specify otherwise using the procedure statement. So we'll see some examples of different ways of doing this. So as a general rule, what most users will do is they will use procedures and use different variable names within those subroutines or functions in order to have reusability and not have any chance of wiping out variables that are in the main program. So they localize, if you will, the variables within the procedure. They pass the values in that they need, and the subroutine function or procedure passes back what the main program needs at the end. So you really localize everything. And remember, the way we pass things back is this result variable on our subroutines. So let's look at some examples of this just to make sure we're clear on where the data is visible and where it's not. So in this case, I'm not going to use procedures. I'm going to just declare a subroutine. And so now all of my variables are visible in both directions. So what I have is I have principal is equal to 100, interest is equal to 0.1, and I say the total is calculate total due, and I'm not passing any parameters. So this is my own self-defined function that I've created here, and it does not require any parameters. So here's my definition of calculate total due, and I say total equals principal times 1 plus interest. So principal and interest are visible from the main program because I have not localized them. Total is visible from the main program. So actually I've got total here in 3 places and I've sort of overdone it, right? So I have total equals principal times 1 plus interest. I return the value of the variable total as the result of the function, and then I immediately assign that to another total. Now, I've used the variable total here in multiple places, but they're all the same variable, right? Rexx does not distinguish between them. I have not localized anything. So I really could have made this just a subroutine and not had to pass anything back because total was very visible right up here. The only reason I had to pass it back was because I used a function, and a function must return a value. So I had to do something on the return statement to return a value because I was calling it as a function. So what if I wanted to create new variables in the subroutine? I could do that as well. In this case, I've still not used a procedure, so all of my variables here are still global, if you will. They're all visible in the main program and in the procedure, in both directions. So I've said loan is equal to 100, rate is equal to 0.1. I've now used a subroutine, call calculate total due, loan, and rate. So what I've done is I've passed in the value of 100, and I've passed in the value of 0.1. I have not passed the variables themselves. I've passed their values into the subroutine. And then the subroutine is going to receive those values via the parse statement, and we'll talk about parse later. Ignore the dot at the end. We'll talk about that later as well. But it's receiving the values that it passed. 100 for loan goes into the variable principal. 0.1 for rate goes into the variable interest. I do some calculations on it, and now I return the value of total. So I'm going to return 110 as the value of total, and so that gets returned in the variable result. Right? Remember, anytime I put something on the return statement and I've called a subroutine, the result comes back in this special variable called result. And that I immediately assign to total due so I do not lose it by calling another subroutine. So both of these ways of doing it are completely valid. You're going to more commonly see separate variables down here, and you're going to even more commonly see procedures, which we'll talk about on the next slide. Okay, so procedures is how you can really localize your variables within your subroutines or functions. So that means there's no visibility of the variables from the main program into the procedure or back again. So anything you use in the procedure is not seen by the main program. Anything used in the main program is not seen by the procedure. You must pass in whatever you need, and you must pass back whatever the main program needs. So let's look at this example. We have total equals 855. That's somewhere else in my program. I'm using it maybe for some other function. And then now I want to calculate a loan rate. And so I'm saying loan is equal to 100, rate is equal to 0.1. I call my subroutine, calculate total due, and I pass it again the value of loan and rate. So I'm passing in 100 and 0.1. In my subroutine, I've used the procedure statement as part of the statement. And so this means now that there is no visibility of the main program variables into the procedure, and there's no visibility of the procedure variables into the main program. So I must receive my variables in. Again, I'm assigning the value of loan of 100 to principal. I'm assigning the value of 0.1 to interest. Now I do my calculation, and I must return that total. So the only thing the main program knows about is the value of what's on the return statement, which is 110. That gets put into the special variable called result. So now result in the main program has a value of 110, and the value of total in the procedure has a value of 110. So if in my main program I make this call, and then I put a message on the console that says, this is your total due, and I put the value of result here. And then I say principal and interest, and I put the values of principal and interest here. But remember, principal and interest were local here. They have no value up here. So what that means is I'm now going to have, sorry about all these, I was already explained all that. This is your total due will be 110. Principal and interest will be the names of the variables in uppercase because they had no value in the main program. So they have their initial Rexx default value of their own name in uppercase. So when you're debugging a program and you start to see one of your variable names in uppercase, that's your clue that you have not assigned a value to it. Okay? So just a reminder, anything I put here now goes into result. The procedure statement says there's no exposure of the variables between the main program and the procedure. I can now use the same variable I used in the main program, but it does not have any impact on that variable back here. The value of total at the end of this call is still 855 in the main program because this is a local variable here. Okay, so what if I'm calling a procedure, but I do not want to have to pass everything in? I want some things to be exposed or visible or global so that I can see them in the procedure and in the main program. So I can do that using the exposed parameter on the procedure statement. So here's the example, that same example we were using before. The main program is exactly the same as it was before. The calculate total due, you see I have the procedure statement to say everything is local except expose says except the variable total. The variable total is now visible in both the main program and in the procedure. So I do the exact same thing here. I'm calculating the total. I'm not putting anything on the return statement. I'm not required to because this is a call to a subroutine, not a function. So there's nothing on the return statement. So the result variable has no value at this point other than its name in uppercase. But because I expose total, the main program still has access to that variable. Okay? So I now get the result that I had before. instead of putting result here, I just put the variable total here. So I get the same result, if you will. I get the same thing on the screen. This is your total due, 110. Principal and interest were not exposed, so they still have their values in the main program of their names in uppercase. Because back here we did not expose those, so they are still local only to this procedure. But remember, I changed the value of total and I exposed it, so that means any value that total had in the main program before has been wiped out and replaced with this new value from the procedure because I made it a global variable. Anything you put on this return statement is going to go into the result variable, and anything you had in the result variable before is gone. Okay, so let's finish up this procedure topic with everything I've been doing so far. I've just been returning like one value, right? A number, for example. But on the return statement, I can return any kind of a string. Remember, in Rexx, by default, every variable is a string. And so on the return statement, I can actually do something like return total due total. I do not have to return just one variable. I can construct any kind of a string to put on the return statement. So if I'm trying to return multiple things, that's how I do that. I just say multiple variable names separated by spaces, and they'll all get returned, put together in a string called result. And then we would parse that string apart if we needed to later, and we'll talk about parse in a few minutes. So again, I'm not limited to just returning one thing. I can return multiple things. I just put them together in a string, and when I come back to my main program, I take them apart with the parse statement that we'll learn about next. So in this example, I'm doing the same calls, the same calculations. I'm saying total due is equal to result, but now remember, result is this whole string. So now my say statement is just total due because it already contains this whole string of total due and then the actual total of 110. Okay? So again, I can put literals here, I can put multiple variables here, I can put anything here that Rexx will allow to construct this string. So the output is still the same, total due is 110 because the full text came across in the result string. So don't think of yourself as limited in result by just one value or one variable. Okay, so now let's go into parsing. I've been referencing it in a couple of places. Now let's actually talk about it. So parse is a special function in Rexx that allows you to take data and tear it apart, break it up into multiple pieces in various ways. So we'll talk about some of them here. There's lots of functions in parse. I'm just going to highlight some of them and go through them, but then you can, of course, look at the help for more information on some of these others. The first thing I want to say about parse, though, is what not to do. But I caution you about this because you might be maintaining somebody else's Rexx program and they did not follow this advice, and they use these short forms for parse. So parse has an option to say, take the data and put it into uppercase. Say parse, upper, and then whatever data I'm parsing. And so the first thing it does is it takes all your data, uppercases it before it starts taking it apart. And so there's a short form of that you can say arg, just use the statement arg, instead of parse upper arg. So what this means is parse upper arg is going to take parameters that you've passed into the program or into the subroutine, and it's going to uppercase them before it breaks them apart into the parameters. Pull is going to do the same as parse upper pull, and pull takes things off of the console or off of the stack, which we'll talk about in part 2. So parse upper pull is the same as pull, parse upper arg is the same as arg. I caution you to never use just arg and pull because the next person reading your program may not realize that you're uppercasing things, and you are. So I always say you should specify exactly what you mean, and you should use parse upper arg and parse upper pull if that's what you want. If you do not want to uppercase it, then you just say parse arg or parse pull. You leave out the word upper. But I'm just cautioning you, if you're reading somebody else's program and you just see this very simple statement, arg or pull, it's really the short form for uppercasing the text first. Okay, so with that caution, let's go into what parse actually does. So as I said, parse takes data that you have and breaks it up however you specify it should be broken up. So the simplest way to do that is to break a string of text into blank delimited words. And so here's an example. We take the string data string, we give it a value of write the blank delimited string. And you'll see I have extra blanks in here at the beginning, at the end, and in between the words. And I've done that on purpose to illustrate what happens. So now I'm going to say parse the variable data string, which I've defined here. And I'm going to take the value of data string and I'm going to break it into first var, second var, third var, and fourth var. And what that means is I'm just doing blank delimiting. So it puts the word write into first var, because that's the first thing that it finds before the blank. And then it takes the, puts it into second var, takes blank delimited, puts it into third var, and takes string and puts it into fourth var. But notice what it did here. It cleaned up and got rid of all of the extra blanks in the first three. And that's because I was doing blank delimiting, which says throw away all the extra blanks around the words. But the fourth one got the whole rest of the string with all the extra blanks. And that's because the rule in Rexx is the last variable in your parse statement gets everything that's left if there is anything. And it doesn't do any more parsing. So what that means is it does not actually parse the fourth word here, and you get just whatever's left of the string. So it's not cleaned up. We'll talk about how to clean it up in the next slide. So what happens when I get myself in this situation? How do I get that cleaned up? Well, there's something called a period or a dot that you can use as a placeholder in your parse statement. And what that does is it's just really, it acts like any other variable specified in parse, except what it indicates to Rexx is this is data I do not want, throw it away. I could have just as easily, instead of putting a dot in the statement, I could put the word junk to indicate to a user reading this program that I want to throw that data away. But when you specify junk, then Rexx now has to keep track of that variable for you, right? And so it's keeping track of something that you really don't want it to. So a dot is just a very quick and easy way to indicate to both Rexx and the human user reading the program that this is data I want to throw away. So let's look at some examples of how we use dots. So I have this data string. It's called last one gets what's left. And in this case, you'll see I've used single quotes, and then I've used two single quotes here to actually use the escape to get the single quote that I want. So now I'm going to parse the variable data string that I've defined here into first var, and then the dot, and then second var. So now first var is going to get the first word before the blank, which is last. The dot is going to throw away the word one, and then second var is going to get the rest of the string, so gets what's left. What you will most often see, though, is a dot at the end of a statement, and that's to say just take the rest of the data and throw it away. Or, as in the case we'll see later, make sure the last part is cleaned up. So in this case, I've said data string is last one gets what's left. I'm parsing the variable data string into first var, second var, dot. So first var is equal to last, second var is equal to 1, and gets what's left gets thrown away because I used a dot to say throw the rest away. What the dot at the end also does is it causes one more level of parsing to happen on the last set of data, and therefore that last piece of the string gets cleaned up. So remember on the previous slide, our problem string, write the blank delimited string, and we had all these extra blanks in it. I now say parse the variable data string into the same first var, second var, third var, fourth var, but I've put a dot at the end. And what that says is now do parsing between fourth var and the rest of the data, and the value of fourth var gets cleaned up with the blanks gone. It's perfectly valid to use a dot or any other variable here if there's no data left. That is not a syntax error. It just means there's no data assigned to it, but it does do this one more level of parsing. Okay, so that was the simple case, the most obvious case of blank delimiting. But what if my data has some other character that's used in it that I want to use as my delimiter? So I can specify either a literal or a variable as my delimiter. So let's take this same data string, write the blank delimited string, and I want to parse it on the dash. Instead of parsing on blanks, I just want to break it into two pieces based on the dash. So I can say parse the variable data string into first var and says everything that's before the dash goes into first var. Everything that's after the dash starts going into second var, but now look, I have a dot here. So now this is blank delimiting between second var and the dot. So what that means is first var gets right the blank, everything before the dash, with all the extra spaces in because I'm not blank delimiting. And second var just gets the word delimited because it's the first word after the dash, and then we do blank delimiting here, and we throw away the word string and all the extra blanks. So the other thing I could do, notice here I put my delimiter in quotation marks, but I could specify a variable for that instead. So in that case, I could take a variable named delim, and I've made that up. You can use any variable name you want. I've assigned it to my delimiter as a string, and I say parse the variable data string, first var, second var, dot, but notice for the delimiter, I specified the name of the variable in parentheses. That's very important. If I had just put delim here, it would have just assigned, I would have been doing blank delimiting and just assigned words as part of the parse statement to the variable delim. So it's very important that I put my delimiter in parentheses. So in both cases, I get the same result, but notice in this one, I'm doing literal delimiting, but then between second var and the dot, I'm doing blank delimiting. So that's why second var is now delimited with no extra blanks around it. Okay? So we can also do positional delimiter. So I can take a set of data apart based on columns. And I can do that in a couple of different ways. The first way is absolute position. So I can say, here's my data string is equal to Kalashaw Mike UK. The scale at the top here is just for convenience. It is not part of the data. So for those who don't know, Mike Kalashaw invented Rexx for IBM exactly 40 years ago, actually. So I say parse the variable data string. The equal one says start in column 1. Put everything you see into surname until you get to column 20, and then start putting everything into Christian name until you get to 35, and then start putting it into country until you get to column 46, and then throw everything else away. That's what the dot is doing. So what I end up with, surname, Christian name, and country are Kalashaw, Mike, and UK, and you'll notice it has these extra blanks in it because I am not doing blank delimiting. I'm doing positional delimiting. And therefore, I'm based on the columns, and all of the data gets put into the variable. I could use relative positional. I do not recommend this, but in some cases it's very handy. I can do relative position where I actually do plus signs here instead of equal signs. So instead of specifying the number of the column, I specify the offset from the previous location. So I start at 1. I go 19 more to get to column 20, I go 15 more to get to 35, and I go 11 more to get to 46. I could also put minus signs in here and go backwards in the data, and that's what ends up making it even more confusing. So it's handy when you really need it, but as a general rule, if you're parsing based on columns, I would recommend using the equal sign so that somebody who's reading your program knows exactly which column you're going after. But in both cases, I got the same result. Surname, Christian name, and country all contain the Kalashaw, Mike, and UK with the extra blanks. So, I told you earlier on the parse statement, how do I get rid of extra blanks? Well, I use the dot. So you might be tempted to do that here. So I might do something like parse the variable data string, the same data, starting in column 1 into surname, and then I specify a dot. So I'm doing blank delimiting here and throwing away all the blanks. And then when I get to column 20, I put it in Mike, put it in Christian name. Again, I use blank delimiting here to throw away the dots, and I do the same for country. So now this looks beautiful, just what I wanted, Kalashaw, Mike, UK with no extra blanks. The problem is it will not work if, for example, Mike Kalashaw had been a junior, because I now have a blank between the comma and the J. So what I would have ended up with is surname starts in column 1 and goes until I reach a blank. So now once I reach the blank, I stop and I end up with only Kalashaw, comma in surname. And then doesn't matter what the data is from here on out after the blank, it gets thrown away until I get to column 20. So I'm mixing blank delimiting with positional delimiting here, and that's what's causing the problem because I might have blanks in my data. So it's important to understand what your data is to understand the best way to parse it is really the lesson learned here. You have to understand what type of data you're getting, what the possibilities are before you determine the best way to parse that data. Okay, so that was the summary. That's part one.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.